All right, so before leading up to this video, we talked about the aldehyde functional group and we talked about the carboxylic acid functional group. And the aldehyde and the carboxylic acid functional groups were part of the carbonyl family. Okay, now in this video, we're going to tackle two more. And the first one we're going to discuss is a ketone, and then after that, we're going to look at an ester. And we need to figure out what these functional groups are first before we talk about where they show up in the infrared, so we know that the differences are there. Okay, just as before, when we talked about the carboxylic acid group, we said that it has to have a C double bond O presence, and that's my carbonyl. So what I'm going to do now is just erase the two things over on the side again, just like we did when we talked about carboxylic acids, and I'm going to get rid of those. So we know that we're still talking about the carbonyl group. And I'm going to come over here and erase all of the OHs because we're not talking about carboxylic acid. And down in the infrared, I'm now going to erase the big dip that we see when a carboxylic acid is present. Okay, so hopefully that will give us a clean slate and we can talk about these functional groups in more detail. Okay, so ester and ketone. The first one I'm going to discuss is a ketone. And a ketone group has to have a C double bond O. That has to be there. So for a ketone, what happens is that this molecule is sandwiched in between two carbons at least. So there is a random alkyl group that sits over here to the left and a random alkyl group that sits over to the right. Okay, the aldehydes had a C double bond OH, right? The carboxylic acid had a C double bond O OH. The ketone is actually in between two carbons. It's in the middle of a compound. And there's a carbon to the left and there's a carbon to the right. But these can be straight chains, these can be rings, they can be anything that they want. So for instance, over here to the side, then if I just simply put another carbon there, that now, my friends, is a ketone. Here in this molecule, if I want to put another carbon here and then maybe put a ring off of that thing, then that is more than fair to do so, and that's still classified as a ketone. It's in between two carbons. This one, if I put a carbon here to the right, it's not a ketone. And the reason is because there's a hydrogen on the other side. So this would not be labeled as a ketone unless I change this hydrogen up and I replace that with maybe another carbon or another ring group or some kind of alkyl group that sits on that side. So that is a ketone. It's a carbonyl in the middle of the molecule. Now, let's talk about esters because we're going to group these two things together. And a ester, again, I'm going to do the same as I did before. I'm going to get rid of one side. And a ester brings in a oxygen and then an alkyl group. And that is what we call the ester functional group. It is a carbonyl that's right beside of an oxygen on one side. So this is a ketone, this is a ketone, and we said that really couldn't be a ketone because there was a hydrogen on the other side, so we just crossed it out. If I wanted these to be ester functional groups, the only thing that I have to do is change that carbon to an oxygen and then write a carbon there. And this is the ester functional group that we see in organic chemistry. The same thing happens here. There was a carbon that was written there. If I just switch that to an oxygen and then have that ring hang over, that now is classified as an ester because it's a C double bond O, O. So the functional group for an ester, if I wanted to write it over here to the side, is a random alkyl group, C double bond O, with a oxygen and then other kinds of random alkyl groups that happen. So aldehyde, carboxylic acid, ketone, and ester. All right, now let's talk about esters first. Esters, these are very nice compounds to work with because they smell, and they actually smell good. Strawberries, their scent comes from an ester. Pineapples, the scent comes from an ester. Bananas, the scent comes from an ester. Rum, the scent comes from an ester. These are all beautiful scents that you would love to plug up into your Wizards or your electric air fresheners and smell all day long. Esters are great. They also make very good solvents, believe it or not. So not only does it smell good, but it can clean well as also. All right, well, the ester has to have a 1700 peak, and the 1700 peak has to be very strong, right? And we said that we don't really call it broad, and the reason is because sometimes it is and sometimes it's not. And then finally, down here at the bottom, I'm just going to erase this 1700 peak. I think that we know what that peak is supposed to be now. So I'm just going to erase the 1700. We know that for this to happen, it has to have a carbonyl band for it to be a carbonyl group. So that is something that I'm always going to look for. And then I'm going to shift this word strong, and I'm just going to write it to the left-hand side because for the first time, we're going to be looking to the right-hand side of this instead of the left-hand side of it. So this has to be strong, and it has to be around 1700. Okay, so for an ester, the ester has to show the 1700 peak, and it typically has two bands. The esters have two bands, two sisters. Esters have two sisters. And those bands typically are in the range of 1300 to 1000. So that's over here in the fingerprint region. We've never really looked at the fingerprint region before, and this is the problem because the fingerprint region is so finicky that sometimes it makes us believe it's an ester and sometimes it makes us believe that it's something completely different. But I would see if this was a clean cut ester, a peak that happens maybe at 1300 and then another peak that happens maybe at 1000. I would see two major peaks that show up on that side. However, they don't have to be as intense as I drew them. They do not have to be the same intensity. One can be a little bit shorter, the other one can be a little bit longer. It doesn't matter. There's no rhyme or reason. And again, this is why I don't like to classify esters and have you pick out just an ester and that's it. Because the kicker here is that if I have a ketone, the ketone will only have one band, and that one band happens between 13 to 1000. So if I see two of these that show up in this range, it is an ester. However, if I only see one of them and that's it, then this is classified as a ketone. And now you see why I have such a problem labeling it as a ester or ketone. And what I do and what I tell you to do is label it as both. The reason, and again, I'm going to write this in big red letters. The reason is that we are working in the fingerprint region. And the fingerprint region is very, very busy. There's a lot of stuff that's going to be happening over in here. that is specific to the molecule. And if I look in the range of 1300 to 1000, and I only look in that range only, and I see something that looks like this, and something that looks like this, and something that looks like that, and maybe a squiggle that looks like this up in here, then if I ask you, is it an ester or a ketone, you're going to look at this and say, well, ketones have one, esters have two, but here we've got multiple peaks that are present. And I don't really know which one's which. Which one should I be looking at? That's the problem. So, the train of thought here. Look at your 1700 peak. If it's present, go down the line. Number one, is it an aldehyde? Do I see bunny ears that happen over here to the left-hand side? If not, is it a carboxylic acid? Do I see a big dip that comes down and then back up? If not, then chances are it's a ketone or an ester. So go then, third, to this area of 1300 to 1000 and look for one or two major peaks. And if you see one or two major peaks that are there, then it probably is an ester or a ketone. So let me show you how tricky these things could be if I wanted to make them that way. This is methyl acetate, and methyl acetate is the smell of Elmer's glue. There's my 1700 peak. It's present. Well, I don't see the aldehyde double bunny ears. I don't see the carboxylic acid dip that comes down and comes back up. So then I look at my 1300 to 1000. So here's 1000 right there. I come up, and then there's 11, then there's 12, and then there's 13, and I come up. This is a very clean-cut molecule. I see one major band that happens here at around 1250, and then I see another major band that happens here around 1050. So this is a ester because there's two major peaks. But on a test or a quiz, I would have you label it as a ester slash ketone. It could be one or the other. All right, here's another example. This is the odor of rum, known as propyl isobutyrate. 1700 peak is present. If I look at the 28 and 2700 range and I come up, there is no band at those locations. It's not an aldehyde. There's no dip that happens in the beginning and comes back up like an OH, so it's not a carboxylic acid. And then I look at my 1000 peak, and that's kind of my cap. And then I go to the 1300 and I go up, and that's my cap there. Well, the problem here is that I see a peak at 1050, I see a peak at 1150, I see a peak at 1200, I see another peak at 1250. So there's more than one. However, which one of these are important and which one of these are not? Well, I don't really know. So I would label this as a ester slash ketone. It could be one or the other. I don't know which one it is for sure, but I know it's probably within those two families or households. Here's another one. This smells like pineapples. Butyl butyrate. Say that 3 times fast. All right, so this is an ester because if I look at the functional group down here at the bottom, C double bond OO. All right, there's my 1700 peak. I see that's present. Over here to the right, I do not see a 27 and 2800, so there's no aldehyde. I also don't see a big OH dip that comes right back up, so it's not a carboxylic acid. And then over here between 1000 to 1300, well, 1000, about 10 or 11, 1050 or 1100, I see a peak that's there. And then at around 1200, I see a bigger peak that's here. And then around 1250, I see another one, and that's there. So I see more than one, but which one is important and which ones aren't, because some of these are a little bit shorter. I don't really know. So I will put here ester slash ketone, and hopefully I'll be able to identify it correctly. But again, I'm giving you the choice of putting down both so that way you feel better about your decision. The next one, this one smells like strawberries and jasmine. So C double bond OO, there's the ester functional group. There's my 1700 peak. That's present. There's no aldehyde double band at 27 and 28. There's no OH dip, so it's not a carboxylic acid. And then between 1000 to 1300, I see two major peaks this time. That's pretty much it. So there's one at 1050, and then here's one at about 1250, and those two are very large and they're very dominant. I would actually go ahead and label this as a ester. And the reason is because it's very clear cut. There's two major ones. They're very deep. They come all the way down to the bottom. There's nothing else that are conflicting my decision. So this probably is an ester, but on a test or quiz, I would have you put ester slash ketone and give you the benefit of the doubt. And then finally, here is the smell of cream and butter. Good cream and good butter, not rancid ones. And this is a C double bond O with an O, and that is an ester group. All right. So there's my 1700 peak. There's my carbonyl. I come over at 27 and 2800, and I come up, and I don't really see a double band, so it's not an aldehyde. And then I look at my OH dip, and I see the OH dip comes down and comes back up. And then I'll be like, oh, it's a carboxylic acid. And that's how I'll label it. And if I do, I'm wrong. This is not a carboxylic acid. And the reason is because look at the shape of the OH group. This is a very smooth OH group that's present. And remember, I kept saying carboxylic acids have very jagged pieces to the bottom and to the bottom right. And if you don't see those jagged pieces, then it probably is a full-blown OH group. And this one's very smooth. Not only that, but this one happens at around 3,500. If the carboxylic acid was present, this is actually shifted down to the right a little bit more, and it interferes with the 3,000 and 3,100 range. That's why those jagged peaks are there. So, this is not a carboxylic acid. This is actually an OH group that's on the molecule somewhere else. And if I look at the molecule down here below, I see that. Look, there's a carbon that has an OH group on it. That is a full-blown alcohol. This OH is not attached directly to the carbonyl. This OH is attached to a carbon. Regular old Joe carbon. And that makes it an alcohol, and that is why I see the alcohol dip here in the beginning. All right, so it's not an aldehyde, it's not a carboxylic acid, and then I go between 1000 to 1300, and I see a peak here at around 1025, I see a peak at around 1050, I see a peak at around 1150, I see a peak around 12, I'll see a peak around 1250. There's multiple peaks that are happening here, right? So which one of these are important? I just simply can't put my finger on it. I don't know which one is which. So because of that, I'm going to call it a ester slash ketone. I'm probably going to put money on the ester because there's more than one, of course, but I'm not really sure. So I'm going to put both of them down. I'll give you the benefit of the doubt. I'll give you a check mark, and you get the answer to the question. All right. Now, ketones. Ketones, we said, are a little tricky because there should just be one dominant peak, right? So here is a ketone. It's a carbonyl in between two carbons. There's my 1700 peak. There is no aldehyde. There is no carboxylic acid. And I go between 1000 to 1300. And at 1000, I actually see a peak here at 11. And I see a peak here that's close to 12. Well, is that one important? Yes or no? It's tiny. Well, I'm not really sure. And ketones are harder to pick out because of that reason. So, if there was one that's important, I would label it as a ketone. But if both of them are important, then I would have to label it as an ester. And that's why I'm telling you to do both. Ester slash ketone. The same thing happens here with acetone. There's my carbonyl. Over here to the side, there's no aldehyde. That actually is not an OH dip because it's not very strong. That's just a little bitty bump. Between 1000 to 1300, well, I actually see a peak here at 11, and I actually see a peak here that's a little above 12. Are both of those important? I don't know. Is just one important? I don't know. But in order for me to determine if it's a ketone or if it's an ester, I'll have to figure that out. So I write down both. Ester slash ketone, one or the other, who knows? My next ketone, 1700 peak. There is no aldehyde group. There is no carboxylic acid group. I come over 1000 to 1300. I see a peak that happens at 1050. I see another one that happens at around 1150. I see one that happens close to 1200. I see a little clump that happens here close to 1300. Which one of these are important? If I think that that one and that one is pretty dominant, that's 2, and that leads me to believe that it's an ester, which is wrong. It's a ketone. Only one of those is actually important that I should count. So again, put down both, and you get credit. And then finally, the last example of a ketone is this one, 5-methyl-3-hexanone. There's my 1700 peak. There is no aldehyde. There is no carboxylic acid dip. I come over between 1000 to 1300, and at 1050 I see a major peak, and then at 1100 I see a major peak, and then at 1150 I see a major peak, and then at 1200 I see a major peak, and then at 1250 I see another little jagged peak, and then at 1300 I see another jagged peak. Well, what on earth? There are multiple peaks that are there. Only one of these is important because this thing is a ketone. Which one should I pick? Well, I don't know. I can't tell you. So that's why I'm letting you write down ketone slash ester. Because if it's not a ketone, it's got to be an ester. That's the only ones that we really look in that area for. Okay? So that sums up the ester ketone identifying those functional groups. And we still have more functional groups that are left. We will still continue on in the carbonyl family because there's more than this. And that's what we'll talk about in the upcoming video. So I know that this was a long one. You probably need a break after this 25 minutes of lecture. And I'll see you when you get back.